Welcome to Algebra 1. Today we're going to look at some patterns to start off with our warm-up. So we're supposed to find the next entry to the patterns. We have figure A2 or figure 1, figure 2, figure 3. So see if you can take a moment and figure out what the next pattern will look like on these problems. Okay, so let's look at this first pattern. We see every time we are increasing 1 to the bottom, so now we'll have 4 on the bottom. We'll have 4 up. Yeah, there we go. And so we sort of get an extra level that's 1 longer every time, and our additional level goes up. That would be our fourth pattern. On our next pattern, we see we're always increasing by another square in our middle. So rather than having 3 squares, we now have 4, and then our little triangles on the outside are pieced off of each of those. And those would be both of our patterns. Unfortunately, we had an issue with our recording today, so also this will be a re-recording, so it might be a little quieter than normal, or go a little quicker than normal. All right. So, based off of those number patterns, or based off of those patterns, we're going to try to transition into a different type of pattern. So we're going to look at these number patterns now. So see if you can think of what the next entry would be for each of these number patterns. So we see for the first one, it's 1, 4, 7. We can see it's increasing by 3 every time, so that puts us at 10. Our next number pattern goes 26, 19, 12. If we look, we're decreasing by 7. And this one was increasing by 3, so every time we're decreasing by 7, which means if we decrease by another 7, that puts us at 5. So we can use these number patterns just like those pictures from before. We can look at what's happening every time, what's staying the same, or what's changing, how am I changing, what is my rule, and then use that to determine our next point. So in Algebra 1, we call these number patterns specifically sequences. So we have a sequence of numbers. We have a pattern of numbers that have a specific rule, they're changing in a specific way. And today we're going to focus on arithmetic sequences. And so the word arithmetic, that comes from our word arithmetic. So arithmetic means adding and subtracting, the lower level math. So these sequences that we're focusing on are always going to have a consistent constant addition or a consistent constant subtraction. So how is it? So for example, our first one was always increasing by 3. It was adding 3 every time. So it's going to keep adding for 3 and go on and on and on. Our bottom one is subtracting by 7. It has a constant arithmetic pattern to it. It's subtracting by 7 every time and go on and on and on. You can keep going on these sequences forever and ever, as far as you want or as short as you want. That's what happens with the sequences. So with these arithmetic sequences, they have a constant rate. So just like constant rates before, we call those slopes in our linear function. So this constant rate would be our slope for our sequence. Or we use our m to denote that. So just like with the linear functions that had slopes, we had a rule that could represent that linear function. Well, just like with these sequences, we can sort of break them down into a specific rule. So in case I wanted to figure out what the 87th term of the sequence is, I could use this rule to help me figure it out. If I want to figure out what the 98th term of the sequence, I could use the rule. And so what this rule will look like, actually before we jump to the rule, let's think about, so I keep using the words term, and when I use that word term, I'm talking about a specific number. So for example, this is the first term of my sequence. And so in order to denote our terms, we like to use a lowercase letter and then a number next to it. So I'm going to call this term a sub 1. This second term will be a sub 2, and then a sub 3. And I could keep going on and on, a sub 84, or on and go a sub k. And so that a sub k is just a number that it's a variable. I don't know what term I'm on, it's just a term. It could be any term. I can keep going on, and I can go to any term number I want. And so we can use these term numbers to help us determine what our pattern is and what the rule will be, what those further numbers are. So these rules for arithmetic sequences, they will always have this consistent formula. It will be a sub k equals a sub 1 plus m times k minus 1. And so let's break down a lot of this. So this a sub k, if we think about these as functions, this a sub k is our output of our function. Just as you had y equals mx plus b, this, lost it. This a sub k is like your y, or your f of x. It's your output of the function. When I input, when I'm looking for a certain term number, a certain k, I'm looking for what is that value. A sub 1, this is always my first term. What is my very first term of my sequence? If I can spell the word first right. So in our previous example, our first term was 1. Our first term was 26. Those are our a sub 1s. M, like we said before, that's our slope. What's that constant rate? What are we increasing by? What are we decreasing by in these examples? And the last part is k minus 1. So this k, that sort of stands for your input. What is my term number I'm using for it? If I'm looking for the 87th term, my input is 87. What does that term equal as my output? So I would input 87, solve this, and that will give you the output. The 87th term is equal to, so on and so forth. Now the reason we have that minus 1 in there is because of how we count. When we count numbers, you never count 0, 1, 2, 3, 4. We count 1, 2, 3, 4. You don't start at 0. But unfortunately, functions start at 0. We always look what's your initial value at term 0, or when x equals 0. So in order to sort of account for that, we always have to have minus 1 to show that when I'm at term 1, it's essentially term 0 function. That's the only reason the k minus 1 is in there, or the minus 1 is in there. Don't let that confuse you. So if we were to use all this information, and we were to try to determine what the rule is for this sequence I have below here, I need to figure out what is my first term and what is my slope of my sequence. Everything else will stay the same. So my rule is going to look like a sub k. That's the output. That's the f of x. So it's going to have that variable in it. And that's going to be equal to my first term. My first term in this problem is -5. It's that very first term that occurs in my sequence. And then I'm going to do my slope. So how is my sequence changing? Well, if I go from -5 to -3 to -1 to 1, that's always increasing by 2 every time. So my slope is going to be a +2. The last step I have is k minus 1. So this would just be like your x and your y equals mx plus b. So if we were sort of to translate some of these to our y equals mx plus b from before, our linear functions and sequences are very, very similar. They go hand in hand. Your output, your y for your linear function, is the same as our a sub k in our sequences. Your input, x, of your function is like k minus 1 of our sequences. Your m is like our slope once again. And then your b is like your first term, your starting value, your initial sequence. And so we can use this information to help us determine what these patterns will look like in the future. But first, let's just start practicing with finding what these rules are, just like what we did in this one. So you take that first term, put that in for your a1, find that slope, put that in for your m. That's all you have to do. The a sub k and the k minus 1 will stay the same. So let's look at this. Let's look at another example. So we have 46, 40, 34, 28. That's our sequence. So we know all of our sequences are going to look like a sub k equals a sub 1 plus m times k minus 1. And the thing is, I need to figure out what that a sub 1, what that m are in my sequence. So if I look, a sub 1 is always my first term. Well, my first term in this sequence is 46. Now, the next thing I need to figure out, what is my m? How is my sequence changing? What's happening? So in this one, I happen to be subtracting by 6 every time. 46, 40, 34, 28. I'm subtracting by 6. So that means my slope will be minus 6. And that's all I need to do for my rule. A sub k equals 46 minus 6 times k minus 1. So once again, just input that a1, input that m, and the rest will stay the same. A sub k will stay there, that's your output. K minus 1 is your input. Those always happen. Just take a moment, just like this problem, see if you can do that next one. What is your rule for this sequence? Okay, so let's look at this problem. So we needed to figure out what our function was, and we should have ended up with a sub k equals 100 plus 15 times k minus 1. There we go. Awesome. You have your a sub k. We saw our first term with a sub 1 is 100. We're increasing by 15 every time, so that's our awesome job. So here we go. All right, moving on. So we were given a pattern. We found a rule. Next thing we're going to do, given a rule, find the pattern. So write the first 4 entries of each of these sequences based off of those rules. See if you can take a moment and figure out what each of those would be. All right, let's look at this first one. So we know those patterns, or these sequences, you always start in that first term, which is, we're told, 4 from our rule. My rule also tells me I'm increasing by 11 every time, so I know 15, and then that puts me at 26, and then 37, and that would keep going on, and this is what we see. The curly brackets, we use those to sort of represent the sequence and show, like, my sequence starts with this and this is going on. Those are the terms of the sequence. They're not necessary, but it's just mathematician to write. Our second one, what did we get? We started at 12, and then we went down by 6, and so we got 6, 0, -6, and so forth. So those are our 2 sequences. So now we know how to, when given a pattern, how to write the rule, or when given a sequence, how to write the rule, when given the rule, how to create the sequence. But what if, so this is good for finding the first 4 terms of my sequence, but what if I want to figure out what the 97th term, or the 18th term, or the 124th term? I can't just keep writing and writing and writing. So what we can use is we can use these rules to help us determine this. So if I want to find the 18th term of both these sequences, 18th, that represents my term number. If I think what my term number is in my rules, those are all my k's. Those k's represent my term number. So if I want to figure out what the 18th term is, I'm looking for a sub 18. That's my 18th term of my sequence. So I'm just going to replace all my k's with 18. That's my input. So I'm looking for the 18th term. All you have to do is replace all those k's with 18, and then we just need to solve. So a sub 1, that's what, or a sub 18, that's what I'm looking for. What does a sub 18 equal? Well, it equals 4 plus 11 times 18 minus 1, which is the same as 17. A sub 18 equals 4 plus 11 times 17. 11 times 17, if we simplify this, that gives us, let's see, 187. Last step, 4 plus 187 equals 191. So that is what a sub 18 actually equals. And so the 18th term of my sequence is 191. Take a moment, using the same method, see if you can try b sub k. What is the 18th term for b? All right. So we should have ended up with a sub k equals -90. What you would need to do is plug, oh, I wrote a sub k, that should be a sub 18. All right, so what you would need to do then is plug 18 into your sequence, just like we did before. 18 minus 17, or 18 minus 1 gives us 17, times -6 is -102. 1 for 12 minus 102 gives us -90. That's the end of our answer. A sub 18 equals -90. That's all you have to do. All right, so now we have lots of things. We know how to find the rule from a pattern. We know how to find the pattern from the rule. We know how to find a random term of our sequence. Let's see what else we can learn how to do. All right, when find the rule of this sequence when you only know a sub 1 and a sub 4. So in this sequence, we're told a sub 1 equals 2, a sub 4 equals 18. We're trying to write the rule. So we're trying to figure out what is that rule of this sequence. What is that going to look like? So if I remember, my rule is always a sub k equals a sub 1 plus m times k minus 1. It always has this pattern. I need to figure out what is that m, what is that a sub 1. Those are the 2 things I need to fill in to be able to write my rule. Well, lucky for us, we were told a sub 1. We're told that equals 2. So I can replace this, and I can write a sub k equals 2. plus m times k minus 1. But unfortunately, I'm not told what my m is. And I don't have a sort of a ability to be able to figure out what the slope is when only I'm given 2 points like this. So we have to think, how can I figure out what am I increasing by just from one term to the next when I'm told 2 different points, a sub 1 and a sub 4? So if we think about this, it's slope. Slope is that constant rate of change that we're always using, that constant rate. When we've determined slope in the past, we've been given 2 points, an x and a y, or an x1 and a y1 and an x2 and a y2. We were given 2 coordinates, and we were able to figure these out by taking our slope was equal to y2 minus y1 over x2 minus x1. And that was able to help us solve for this solution. The thing is, I don't have 2 coordinates on here. I only have 2 terms. But like we said before, that term number of each of these terms kind of represents the input of that term. And what that number equals represents the output of your sequence, the output of that term. So in a sense, I could rewrite a sub 1 equals 2 as a coordinate point. My term number is 1. What that term equals is 2. A sub 4 equals 17 is my term number 4. The term equals 17. So we can use this as sort of an input-output to sort of create coordinates for us based off the information we're given to be able to actually find what the slope is. And then we can just use that same method. y2 is 17 minus y1 of 2 divided by x1 of, or x2 of 4 minus x1 of 1. This gives me 17 minus 2 is 15 divided by 3, which equals 5. And so I know I can then replace my slope with 5. And my rule is a sub k equals 2 plus 5 times k minus 1. And that would be my rule. So the main trick is to recognize a sub 1 equals 2 and a sub 4 equals 17. That's really just another way of writing these coordinates. X is the same as your k, y is the same as your output, your number. And so we can replace those numbers into coordinates. We can use them to then solve for these problems. So let's try another one like that. One more. So I have a sub 1 equals 4 and a sub 7 equals 22. Take a moment, see if you can use this method, create the coordinates, find the slope, and write the rule that this sequence would have when given those 2 points. A sub 1 equals 4 and a sub 7 equals 22. All right, if we come back and we relate to this, we can think, all right, I need to write these into points. So my first point would be 1, 4. My term number is 1. My term is 4. My term number 7, what that term equals, is 22. These are my 2 points. In order to find the slope of my sequence, I need to do my rise over my run, my y2 minus y1, my x2 minus x1. So that gives me 22 minus 4 divided by 7 minus 1. 22 minus 4 gives me 18. 7 minus 1 is 6. This leaves me with 3 as my slope. So now that I have my slope, I need to input that into my rules. I know my rule is a sub k equals a1 plus m times k minus 1. Let's put in this information. So a sub k, that will always stay there. A sub 1, do I know what a sub 1 is? If I look back, it's 4, so I'll put in 4. Plus m. My m is my slope, which I'm told is, or which I found was 3, and then k minus 1. So that's all we have to do, and we solve. And that's where we'll stop for today. We'll continue to practice sequences throughout the week, and learn a little bit more.